Hello folks, in this video I am going to attempt to share with you my exposure and experience with the routing protocol ISIS. So what I am going to try to do is, this question has always kind of boggled me about which one to choose between OSPF and ISIS. So here I did a little research, and this is what I've kind of come up with is that OSPF versus ISIS. Now, if you're a network engineer and experienced one, you will probably have seen OSPF in a lot of enterprise networks. And that's primarily because you will find OSPF expertise more commonly because it's being deployed pretty much with all the vendors, and it's used very often and frequently. Versus ISIS, you have probably seen in the service providers. And it has always bothered me to figure out why or which one to choose. And I think I've begun to appreciate ISIS more. And I will share my thoughts in terms of why. Even though OSPF may give you more customization, which ISIS does not, but from a scale perspective, it is definitely the way to go. Scale, the operations of it, operational, view or configuration of it, and obviously the implementation and design is rather simple compared to OSPF. So if you've been using OSPF, and obviously, what I've seen in my experiences, if you are managing or you've been in a small to medium-sized network, you will not see OSPF. You'll probably see static routes. You'll probably see EIGRP. But OSPF is large enterprises, and then service providers are very large networks, right? What's the reason? So let's kind of draw a picture. OSPF is highly dependent on area 0. If you do not have an area 0, which is considered a backbone area, your routing will probably break unless you configure one area all across your network. Then that beats the purpose of OSPF. You can probably use EIGRP instead, because now EIGRP is a open protocol. It's available for non-Cisco as well. Initially, it was only Cisco. So now it's available to other vendors to deploy. And I've seen it in VIOS deploying EIGRP as well. But OSPF is backbone area is a requirement if you were to create other areas. Now again, we're talking large enterprises where you're talking, large amount of net routers, big networks. Small to medium, like I said, even if you use OSPF, you'll just use one area, and that area could be numbered anything. like area 1, 2, 3, whatever. But if you want to go multi-area in OSPF, you must use area 0. So that's a requirement, hard requirement. So this is going to be, let's say, area 1, and this is going to be area 2. Now in this scenario, these ABRs, area border routers, that share 2 or more areas or backbone area, they're the only one that can summarize. Summarization of the prefixes, right? So now, so that's one thing. You can only summarize on ABRs. OSPF gives you the flexibility of configuring areas as stubby. It can give you the flexibility of configuring as not so stubby area, not so NSSA, and totally stubby. So there are like 3 different variations where you can go with a non-backbone area, which you would not find in ISIS. Again, it's a lot of configuration. It's a complex, operationally becomes very complex. So if you're considering which one to deploy, you need to not only just look at the flexibility OSPF gives you, but also the operational. And operational, when I mean operational, it's like automation and implementation and troubleshooting and all of that good stuff, right? You need to consider all that good stuff. OSPF becomes way complex to do all that stuff. Number 2, the number of LSAs. The LSA is a piece of information that a routing protocol exchanges. The number of LSAs that OSPF could potentially exchange is 7 or more. Well, at least 7, not more, right? There could be more, but at least 7. Now, that flood of information is obviously, well, the more information you flood, the more time it takes. And therefore, when it takes more time, it affects your convergence. With ISIS, you don't have the dependency of areas. It's very simple. You have routers that are either L2 type, level 2, level 1. Level 3s are like host based, right? So we'll discuss from a routing perspective, transit perspective, level 1, level 2. Level 1s are similar to area routers in OSPF. So they're like stub. Stub means that there's no transit. So they're like stub network routers, no transit. And L2s are more transit core router. So if you're deploying a core, you just go with L2 only. But if you're deploying something like this, where you have your entire network is ISIS, then you're going to go L1 router with a stub network connecting to L1, L2 router, because L2 by itself does not talk to L1. So you can have a router that's configured as L1, L2 that talks to L2 only, which is a pure core router, does not talk. So this is more like an ABR function. You don't have to have L2 either. You can have L1, L2 talk to L1, L2, but just for example, L1, L2, and then L1. So this would be an equivalent, if you were to draw areas, this is how it's going to look like. But this is your ABR, this is your ABR right here too. But the areas on OSPF exists on interfaces. So this ABR interface, this one is in 0, this one is in area 2. So it's an interface dependent area design. Whereas the areas in ISIS is router dependent. It works on the router. So this whole router would be, all the interfaces on this router would be in area 1, let's say. And then this whole router would be configured as whatever area you want. There is no 0, so area 2. And then this router could be area 3. And again, areas are only required when you need to do something or prevent flooding of your information, like in OSPF, the flooding is happening in the areas and then across the areas if the ABRs are configured in that way. Now, in ISIS, there's only 2 pieces of information, and it's called LSP instead of LSA. And that is only 2 types, L1 type and L2. So when you look at the database of OSPF, you'll see a lot of information, right? When you see the database of OSPF, you'll see a lot of information. The ISIS database is very simple. If you configured one area specific, so this guy will only have one database. This guy will have 2 databases. And it will have area 1 database, and it's going to have area 2 database. So if you're configuring for a core network, you will probably just keep it in one area. But again, even if it's got 2 areas, it'll only have 2 pieces of information. And all the LSPs includes all the link information, the loopback, the stubs, the transit, everything is included in one LSP. Whereas in OSPF, every link has an LSA. Every link has an LSA. And then on top of that, the DR, the designated router, generates an additional LSA. You can see my video on that, on how OSPF generates LSA. But now you can really see the difference from 7 LSAs to only 2 LSPs. And now, and obviously, you know, you're creating areas, just areas for flooding, right? If you wanna, there's a change or there's a change in network, the flooding happens within an area, and then you can control that flooding between the areas. But if that flooding is very small or that network is not that big, then you can create this whole thing as 1 and keep everything as L2. Core routers, core networks are only a phenomena of large networks like service providers or very large enterprises. Service providers have like maybe hundreds or even thousands of routers in their core, just the core, transit, right? These service providers are worldwide tier 1 service providers carrying international internet backbones. So for them, keeping the L2 as their core and using ISIS makes more sense because it's just going to be 1 DB, 1 database, and only 2 pieces of information included. So it's very quick to flood, very quick to calculate, less time, quick convergence. The other good thing about ISIS is it is a non-IP protocol. That means it doesn't require IP protocol. OSPF is an IP-based protocol. You need IPv4, v6. It sits directly on Ethernet frame. So that's another advantage. And having that advantage gives ISIS the capability or ability to carry IPv4 as well as IPv6 in the same process. Same process. You don't have to configure 2 different processes, one for IPv4, one for the same ISIS configuration, It's just gonna be 3 lines, and you will be able to enable IPv4, IPv6 routing. Whereas in OSPF, you're gonna have for IPv4, you will have to have OSPF v2, and then for IPv6, you will need OSPF v3, and the configuration is a lot more for OSPF, and I'll put further videos comparing that. But ISIS, the only scary part in ISIS is the NSAP number or the network number. That is, you know, kind of, once you get a hang of it, it's not that bad. It's essentially an area and system ID identification. And it looks like something like this. So the network number for ISIS, you configure the router process, is something like this. I need to enable my pen for some reason again and again. Okay. The network number for ISIS has an anatomy of like this. So it's got this format. Let me kind of erase this to clear up this stuff. XX dot, and I'll just use the numbers 1, 2, 3, 4, so it's easier to read. 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, and then you got this. This is the format of the network number that you use in ISIS, and after that everything is just pretty straightforward. This is always 49. There's a history to it. ISIS was developed back in the days thinking it's going to be the dominant internet protocol, so they divided the publics versus private addressing, but now BGP is pretty much the dominant protocol in the internet. So the ISIS is not used as interdomain routing. So now this is a private addressing number that ISIS uses, and that's how everybody pretty much standardized it. 49 is going to be a standard number, and then after this guy is usually the area number. And then from here to here, this is going to be your unique system ID, which should be, this could be same across the routers or different depending on your topology, but this one needs to be unique for all the routers. So you can pretty much come up with whatever number you want, but it has to be unique on all the routers, and this stays as 0, unused or / reserved for future use or something like that. But once you get a hang of this, your ISIS configuration is pretty straightforward. You just say router ISIS, and then put this network number and the type of router you're creating, IS type, L1, L2, or just L2, and that's it. And you go on the interfaces and enable ISIS there. And you can configure on that interface either IPv4 or IPv6. can go with start with IPv4, enable IPv6 later, and nothing needs to be configured here after that, right? So, and that's it. That's a very straightforward configuration once you get a hang of the network number. And then you will get to appreciate how INSIS kind of works. But again, the reason it's not very popular in the enterprise, again, the expertise, this, it's not pushed or required in medium enterprises, large enterprises. People are more familiar with OSPF. And ISIS is obviously, since it's more thin or lightweight, I would say definitely, because it doesn't have so many LSAs to flood. The time to converge, it's only got two type of piece of information that contains all the link information. So the time to convergence is very quick, calculation and all that. So ISIS kind of scales, and operationally it's definitely easier to deploy. And implementation and design is very, very easy compared to OSPF. But again, if you want to get into a lot more customization, which I don't think is absolutely necessary, but could be required in certain scenarios, then OSPF kind of, you know, especially the non-NSSAs, TSA is pretty much L1 to L1, L2. But you know, stubby NSSA and all that good stuff is something that OSPF only support, and it becomes operationally difficult to do and implement and design. But again, ISIS is primarily used in the core because you don't need much customization in transit networks. You have a core network, and then everybody else is hundreds of thousands of routers, and then everybody kind of connects from here via BGP, and this could be a BGP based isolation, and you can be running OSPF here, and then on the edge you can be using BGP, that's how, and in the core you have ISIS and BGP on the edge. So ISIS is very popular in the core, large cores, because it scales well, it's operationally very simple to deploy from design and implementation perspective. And number two is obviously, again, the protocol family, V4 and V6 is so easy to enable compared to OSPF. So I think that is and the last thing, I think the summarization is in ABRs in OSPF, whereas in ISIS only L2 supports summarization. So I think that is I would think not a drawback, but you know, if you have to summarize, if you have a core with L2s, that kind of gives you the flexibility, but summarization kind of is a tricky business anyway. But that is a high-level perspective of ISIS OSPF, and I've been using OSPF for a long time. But my current assignment kind of enabled me to look into ISIS. I think I've come to appreciate this one much more than OSPF, and so I think ISIS, the expertise for ISIS is definitely useful for large networks and as a skill set. And it's easy to develop, a very easy skill set to develop. Vion supports it, Cisco supports it, Juniper supports it. But once you get a hang of this and L1, L2 stuff, you're pretty much there. Hope this helps.